So hello everyone. Now let us discuss about the vitamin D metabolism, and in this video also we will discuss about calcium and phosphorus homeostasis. Basically, I will divide the video in two parts. In first part, I will basically discuss about various nomenclature of vitamin D, the active forms of vitamin D, and other various forms of the vitamin D. Um, I'll also discuss the various effects of vitamin D on calcium and phosphorus homeostasis, and I'll discuss the role of thyroid and parathyroid gland in calcium homeostasis, and also I'll discuss the regulation of production of the most active form of vitamin D, that is calcitriol 1,25 dihydroxycholecalciferol or 1,25 dihydroxy vitamin D. So first of all, in this video I will mainly discuss about the formation of the 1,25 dihydroxy vitamin D, also that is known as calcitriol or 1,25 dihydroxy cholecalciferol. Now let us discuss about various nomenclature. So you have to know that vitamin D3 is also known as cholecalciferol, and 25 hydroxy cholecalciferol is also known as 25 hydroxy vitamin D. So whenever I say vitamin D3 or I say cholecalciferol, it is the same thing. Or whenever I say 25 hydroxy vitamin D, it is equal to 25 hydroxy cholecalciferol. And the 1,25 dihydroxy vitamin D is also known as calcitriol, or also you can say it as 1,25 dihydroxy cholecalciferol. So again, in the nomenclature, don't be misunderstood, don't get confused. Whenever I say vitamin D3, it also denotes cholecalciferol. Whenever I say 25 hydroxy cholecalciferol, it is also 25 hydroxy vitamin D. And calcitriol is also known as 1,25 dihydroxy vitamin D or 1,25 dihydroxy cholecalciferol. So now let us discuss the formation of the calcitriol in the human body. So we all know that in our skin there is 7-dehydrocholesterol. So whenever there is the strike of the solar UVB radiation in our human body, there is formation of the pre-vitamin D3, and due to heat, the pre-vitamin D3 is changed into vitamin D3, and also we get vitamin D2 and vitamin D3 from the dietary products. So what happens? The vitamin D3 binds with D binding protein in the circulation, and in the circulation vitamin D3 combined with D binding protein, and that D binding protein transport the vitamin D3 to liver. So in the liver, the vitamin D3 is converted to 25 hydroxy cholecalciferol by the enzyme 25 hydroxylase, and another one is CYP27A1, CYP and other various CYP enzymes. So what happens? This 25 hydroxy cholecalciferol is transported to kidney, and this 25 hydroxy cholecalciferol is changed into 1,25 dihydroxy cholecalciferol or calcitriol by the enzyme 1-alpha hydroxylase. So the calcitriol is most active form of the vitamin D, and there are various effects of the vitamin D on the calcium and phosphorus homeostasis, and also there are various other effects that helps in the metabolism of the calcium and phosphorus and vitamin D. So now let us discuss about the various effect of vitamin D or various effect of the calcitriol on calcium and phosphorus homeostasis. The calcitriol stimulates the intestinal absorption of the calcium, and the calcitriol stimulates the intestinal absorption of the calcium, so it increases the level of the calcium in our body. The calcitriol also stimulates the calcium reabsorption in the kidney. And calcitriol, with the interaction with parathyroid hormone, it regulates the blood calcium. So vitamin D3, I mean the calcitriol keeps the calcium and phosphorus in supersaturated level in the plasma, and parathyroid gland, by the action of the parathyroid hormone, regulates the extracellular calcium accordingly. So if there is increase in calcium or decrease in calcium level in our body, there is response of the parathyroid gland. How the thyroid and parathyroid gland maintains the calcium homeostasis, I will discuss detail in subsequent lectures. And also the calcitriol helps in the mineralization of the bone. So these are the main effects of vitamin D on calcium and phosphorus homeostasis. Now let us discuss brief about role of thyroid and parathyroid gland in calcium homeostasis and regulation of production of the 1,25 dihydroxy vitamin D or calcitriol. So now I will explain this in brief, and in the subsequent lecture I will discuss this in detail. So whenever there is hypocalcemia, there is response by the parathyroid gland, and parathyroid gland increases the parathyroid hormone, and the parathyroid hormone increases the activity of 1-alpha hydroxylase. So now what happens when the activity of 1-alpha hydroxylase is increased? Whenever there is hypocalcemia, by the action of the parathyroid hormone or parathyroid gland, there will be the increased activity of 1-alpha hydroxylase. If there is increased activity of 1-alpha hydroxylase, then there is more conversion of 25 hydroxy vitamin D to 1,25 dihydroxy vitamin D. So there will be the more production of this calcitriol, and the calcitriol, as I have already told you, that the calcitriol, after forming the more amount of calcitriol, then there will be the more stimulation of intestinal calcium absorption, more stimulation of calcium reabsorption in the kidney, and the level of the calcium in the body will increase. Now let us suppose there will be the hypophosphatemia. If there is hypophosphatemia, the hypophosphatemia directly stimulates the 1-alpha hydroxylase enzyme. When there is hypophosphatemia, the 1-alpha hydroxylase enzyme activity will automatically increase. It directly stimulates the 1-alpha hydroxylase enzyme. So if the enzyme activity of 1-alpha hydroxylase enzyme increased, then there will be the automatically increased amount of production of calcitriol, and the effect are seen accordingly. So there is one feedback regulation. If there is increased amount of calcitriol production, 1,25 dihydroxy vitamin D, then the calcitriol itself inhibits the activity of 1-alpha hydroxylase enzyme. So if the level of calcitriol is more, then it itself inhibits the 1-alpha hydroxylase enzyme, so that the more production of the calcitriol will not take place. And what happened? We talked about hypocalcemia, we talked about hypophosphatemia, we talked about the increased level of the calcitriol. So what happened when there is hypercalcemia then? If there is hypercalcemia, if there is increase in calcium level in our body, then the thyroid gland will come into action. The thyroid gland will produce the level of calcitonin. The calcitonin has opposite effect of this. The calcitonin has opposite effect of the parathyroid hormone. The calcitonin will stimulate the osteoblast, so that the more layer of the bone will be deposited. So in the bone, the more level of calcium will be deposited by the action of calcitonin. So the serum calcium level will be decreased, and it decreases the intestinal calcium absorption, and it also decreases the calcium reabsorption in the kidney. The main action of calcitonin is like this. So we discuss about the nomenclature, we discuss about the active forms of vitamin D, we discuss about the various effect of vitamin D on calcium and phosphorus homeostasis, and we also discuss of the role of thyroid and parathyroid gland in calcium homeostasis, and also we discuss about regulation of production of the 1,25 dihydroxy vitamin D. So these are the main things, or these are the main core concept, how thyroid gland and parathyroid gland maintains the calcium and phosphorus homeostasis. I hope you understood this lecture. Thank you.